Hello, good morning, good afternoon. I'm just going to do a video on parametric integration because why not? And if you feel like it, you give it a go, you have a look. And if you rather work on something else, entirely up to you, okay? Now, so we have the situation where we are given, the two parametric equations, and they ask us to find the area under a curve between two limits, right? We have to integrate. The problem is that typically what we do to find the area is integrate the y function relative to x, but the y function would be in terms of x, right? But the problem is we haven't got a y function. We don't, relative to x. We have a y function relative to t, but we do not have a y function relative to x. All right? So, what we have to do is sort of manipulate a little bit. So in order to find the area, the y function is going to be the parametric for y. But the problem is that the parametric for y is in terms of t, and we have to integrate relative to x, so what are we going to do? What we're going to do is we're going to take the parametric for x, and dx over dt is going to be f prime of t. And if I rearrange, dx is f prime of t dt. And I can substitute this into that, so that the area under a curve is the integral of the parametric for y relative to t multiplied by the derivative of the parametric for x relative to t, and then I can integrate that, or hopefully you can integrate that, okay? So the method, if you want, the method to find the area under a curve that is given in parametric terms is to integrate the product of the parametric for y times the derivative of the parametric for x, all right? But, so this is the general form. You don't need to learn that. You need to learn that, but what I mean is, that's just the general explanation. It's not a formula that you have to have in your mind. And then we're going to do a couple of examples and take it from there. Shall we? I wish I had a bigger board, but hopefully you've taken notes of these. I hope it's, well, it may not be 100% clear, but bear that in mind when we do our example. So, I've got two parametric equations, and they ask me to find the area between t equals 1 and the area under that curve between t equals 1 and t equals 2. Well, I know the area is going to be the integral, we said, of the parametric for y multiplied by the derivative of the parametric for x, how nice, dt. Integrate 3t squared shouldn't be a problem at this point in time. Substitute 2, substitute 1, take them away from each other. The answer is 7. Fantastic. If only every question was like this. Unfortunately, not every question is going to be like this. So this is example 1. Shall we have a look at example 2? Let's. Right, we've got again two parametrics. The parametric for x is going to be cos t, and the parametric for y is minus cos t, and I want to find the area between pi over 6 pi over 4. Well, when I use exactly the same method, the area is going to be the integral between pi over 6 and pi over 4 of the parametric for y minus cos t multiplied by the derivative of the parametric for x. The derivative of cos t is minus sine t. Okay, the minus times the minus is a plus, so this is the same as the integral between pi over 6 and pi quarters of sine t cos t dt. And I have to integrate sine t cos t. Cast your mind back to Q3. Remember, and they have a way to sneak and creep when you least expect them. How do we integrate that? You need to know your trig identities, remember that? So remember that sine 2a is 2 sine a cos a. So this thing here is sine 2t divided by 2, yeah? Because sine 2a is 2 sine a cos a. I've only got sine t cos t, so it must be a half. Alright? Now, we're going to integrate this, which is the same as 1/2 the integral between pi over 6 and pi quarters of sine 2t, which is 1/2 the integral of minus cos 2t between pi over 6 and pi quarters. Right? It's not right. It's not right. You need to remember this thing here is my first attempt at integrating. We need to adjust coefficients. If I differentiate this, I am not going to get to this. I'm not. Because if I differentiate that, what I get is 1/2, because the 1/2 is there, minus 1/2. The derivative of cos 2t is minus sine 2t, and then times 2 because the chain rule. So minus and the minus is a plus. The 2 divided by, so what I get is sine 2t. If I differentiate that, I get this. What I actually had was that divided by 2. So if when I differentiate that, I'm getting double what I had. I need to take that and divide it by 2. Remember the whole adjusting coefficients? So the actual integral I'm looking for is minus cos 2t divided by 4 between pi over 6 and pi quarters. That's the actual integral, okay? And then I'm just going to leave the substituting of pi quarters and pi over 6 into it, and you take them away from each other, but it turns out that the answer is actually 1/8. That's not the difficult thing. The methodology here is not difficult, isn't it? You put the parametric for y in there, you multiply it by the derivative of the parametric for x and integrate. And then we're back to Q3. Adjusting coefficients, trig identities, all that kind of stuff. The actual PU4 content or new concept is not difficult. You need to be very comfortable and remember well all your integration for PU3.